So in this video, we're going to look at some harder common factoring practice problems. So the question asks, factor the following expressions. So let's get right into this. Question A, 4x to the 5 plus 40x cubed plus 12x to the 6. So, and before we get started here, I'm just going to paste our rules here from last time. And our rules here, once again, are only like terms can factor each other. Part two is when dealing with numbers, we're going to find the lowest common denominator. And part three is we're going to always factor to the lowest possible term. Now, these three rules can actually be summarized into what we call our greatest common factor, which is basically just summing up these three rules into one term there. So let's get into question A here. So A, if we look here, we got 4x to the 5 plus 40x cubed plus 12x to the 6. So we're going to look starting at our numbers just like last time. So 4, 40, and 12. So if we look at those, is there any lowest common denominator that we can find between those? Well, each of them can be divided by 4. So that would be our lowest common denominator between those. Now, the only other terms that we have here are these x terms. Okay, so they're all like terms because they all have x, but our first one is to the 5, and our next one's to the 3, and our next is to the 6. So that means we got to look at whatever is the lowest number of x's we have, which would be this 3 here, right? That is how many we're going to be able to take out of all of them. So we're only going to be able to take out x cubed from all of them. Okay. Now, if you remember, when I say take out, it's not subtracting, we're dividing each of the terms. So you can see here, we're taking 4x cubed. That is what is known as our greatest common factor. Okay, so we're going to factor out 4x cubed, and we're going to be left with, well, this first term, 4 divided by 4, is just 1, right? So I don't even need to write that, because then x to the 5 divided by x cubed, well, if you remember our exponent rules here, if we have x to the 5 divided by x cubed, well, division in the exponents becomes subtraction. So this will just become 5 minus 2. So this will become x squared. Okay. Now, next term, 40 divided by 4, well, that's 10. And x cubed divided by x cubed, that'll cancel. So we just have 10 in that next term there. In our last term, 12 divided by 4 is 3, and x to the 6 divided by x to the 3, well, like we said before, if it's exponents and they're dividing, it actually becomes subtraction. So this will be x cubed. And that's the answer to our first question there. Now let's go on to question B, which is 7x to the 5 plus 9x cubed y. Okay, so if we're looking at this one here, we've got our numbers, which are 7 and 9. We've got our x terms, and then we've got one y term over here. Okay, so if we start with our numbers here, 7 and 9. Well, 7 is actually a prime number, meaning it can't be divided by anything except for 1 or itself. And we also can't divide 9 by 7 and get a whole number. So in this case, there's actually no number to divide by here. So we can't factor out any number. So let's move on to our x terms. Well, x to the 5 and x to the 3. We're going to look for the lowest number, so x to the 3. So that means we can factor out x cubed from each of these terms. And now this y here. Well, y is only in this right term over here. It's not in that left term, meaning we won't be able to factor that out either. So the only thing we're going to factor out is this x cubed. So what this will look like is x cubed bracket. Now we didn't touch the 7, so the 7 still stays. Now x to the 5 divided by x cubed. Well, 5 minus 3, because it's in the exponents, it becomes subtraction. It's going to become x squared plus, and once again, we didn't touch that 9, so we're going to leave the 9. X cubed divided by x cubed, it'll cancel. So that term just becomes 1. And then our y term wasn't touched, so plus 9y. And that is our answer to question B there. Now question C. Question C is, and I'm going to bring this down here. So question C reads 5x squared y to the 4 plus 15x to the 5 y cubed plus 60x cubed y to the 4. Okay, so same thing. Let's start by notifying our like terms here, writing them out. We've got our numbers 5, 15, and 60. Now our x terms here, I'm going to do 2 underlines. Okay, and our y terms, I'm going to do 3 underlines. So there's all our like terms there. So let's start with our numbers. Well, 5, 15, and 60, what number can we divide all those by? So take a second and pause and try to figure this one out before we continue. So 5, 15, and 60, well, we can divide all those by 5. Okay, so now on to our x terms. So we have x squared, x to the 5, and x cubed. So we got to look at what our lowest one is. So that'll be the x squared, meaning we can factor out x squared from each of the terms. And now y to the 4, y to the 3, and y to the 4. Well, y to the 3 is our lowest term, so we can factor y cubed or y to the 3 out of each of these terms here. So that means we're factoring out 5x squared y cubed. So this will look like 5x squared y cubed bracket. Now if we look at this first one, well, 5 divided by 5 is just 1, right? But we won't need to write that as long as we're left with an x or a y term. Well, x squared divided by x squared is just 1. But now we have y to the 4 divided by y to the 3. Well, this will just become 4 minus 3 since it's in the exponent. So we're just left with y to the 1. And we actually don't even need to write that 1 there. We can just leave it as y. So now on to this next term. We have 15 divided by 5. Well, that is equal to 3. X to the 5 divided by x squared. Well, 5 minus 2 is 3, so we'll have x cubed. And y to the 3 divided by y to the 3, or y cubed divided by y cubed, that'll just cancel. So that's our second term. Now our last term here, 60 divided by 5 is equal to 12. X cubed divided by x squared is just going to leave us with x to the 1, but we don't need to write the 1. And y to the 4 divided by y cubed is just going to leave us with y, meaning our final answer for this one is 5x squared y cubed bracket y plus 3x cubed plus 12xy. And those are some more complicated common factoring questions.